The cloud has enabled mass connectivity of people, of resources, of information that was never possible before. Data and software used to be standalone, unconnected, slow, and limited to our personal use. Today, we tap into the power of thousands of interconnected computers. They provide an amazing array of capabilities that make the world a smaller place. And that's really the power and the beauty behind it. That constant connection, sharing video and pictures, planning vacations with family and friends, social networks, search applications, streaming content, email, using GPS, and having it all in the palm of your hand. It creates a feeling of being closer. But cloud computing doesn't just benefit personal use, it benefits businesses too. They rely on the cloud for enterprise applications to scale capability and services in real time without having to depend on a cumbersome internal infrastructure. The cloud enables us to access information and applications at any time from almost any place. And whether it's 3 people or 3 million people, there's an expectation that it will work instantly and flawlessly. The ability to store and analyze huge amounts of unstructured data extends into some of today's most challenging big data problems. We're going to get to a point and say, hey, I'm going to my 10th year reunion, and I want to find a picture that I took 10 years ago. And I don't want to wait any longer to get that picture than the picture I just took yesterday. As a cloud provider, meeting this user expectation of instant and affordable access to data is the first challenge. Then you've got to make sure that data is reliable and always available. The last thing anybody wants is an outage. And then, of course, there are always cost and physical limitations that apply to all of us. So as usage and demand for spontaneous access grows, it drives a bottleneck in the data center that can be directly linked to hard disks. Hard disks today have been around for so long that nobody really thinks about them anymore. Engineers have spent tons of energy building whole systems that are designed to offset their inefficiencies. But the truth is that hard disks cannot keep up with the processing power of the data center, and they require a large amount of energy both from a power standpoint and from a cooling standpoint. And this is where solid-state drives come in. SSDs provide a huge cost savings. They need less power to operate, they run cooler, and their higher performance allows you to optimize your system for cost. So the operating cost and the carbon footprint of the data center that deploys them shrinks. But not all SSDs are created equal. While SSDs are 1,000 times faster than hard disks at the physics level, many SSDs rely on controllers that are inconsistent, that let the work pile up. This undercuts the value of using SSDs. Why put a faster drive in your data center that isn't fast all the time? Intel has designed its own controller that has very tight, predictable IOPS, making it fast every time you need it. Now, this is where things get interesting. Imagine spending less energy worrying about the data and where it sits on the disk, and more about the user interface or another piece of that system. Intel SSDs are breaking the paradigm of the traditional storage model for the data center. A hard disk is spinning around in a circle, and there's something mechanical measuring magnetic fields off a rotating disk moving at the speed of rust. It's an antiquated technology. A semiconductor operates at the speed of light. It's 1,000 times faster. That's like being able to fly to Shanghai in a minute, as opposed to 10 hours. And if you could do something 1,000 times faster, you really don't just do the same thing. If it only took you a minute to fly to Shanghai, how often would you go? You would change the way you use transportation. It would fundamentally change what it is that you do with technology. Intel SSDs are not just a little faster, or a little cheaper, or a little more consistent. They are consistently amazing. SSDs are fueling innovation in the data center. And with the right computing behind them, we're able to do things and provide services to people that were just not possible before.
Good morning, ladies and gentlemen. Please welcome our Day 3 Cloud Expo New York keynote speaker, Intel Corporate VP and General Manager of the NVM Solutions Group, Rob Crooke.
Good morning, and thank you for that. Well, good morning. Happy Wednesday, and I think it might be happy Wednesday afternoon to the folks down on the east end of this long room. But we've got some exciting things to talk about here today around storage and how it impacts the big data and cloud computing paradigms. And I first wanted to say that this is an unbelievably exciting time to be a leader in an IT shop. For the IT professionals out there, there's an enormous amount of change happening in the industry, both in the technology that you use to do the computing, as well as the business models and the way you're doing the computing. And the way you embrace this change or the way that you avoid this change will have significant impact on the success of your company. So I can't think of a more exciting time to be an IT professional or a leader in an IT shop. And I'd like to talk about just one of those areas. I'd like to focus on how storage is impacting both cloud and big data. And we know that this data explosion is driving a transformational change in the way you do computing, that there are hundreds of millions of new intelligent devices coming on and being connected. Of course, there's tons of smartphones bringing enormous amounts of information, and tablets and ultrabooks being connected to the network and driving new sources of data. But there are also an enormous number of new intelligent embedded devices, smart signs with screen capture and cameras on them, giving you new information about what's happening around them, weather stations, business partners driving information back to you about what's going on in their businesses. And that's driving enormous amounts of new data, which you all are here trying to learn how to deal with as best you can. The good news is that also, to go along with that, there's been exponential change in the computing available for you to analyze that data. And though to go along with that, we're dealing with some business model changes in how we go about doing the computing. And the challenge for us really is to take that enormous amount of information and how quickly we can turn that into usable information to help our businesses succeed more tomorrow than they did yesterday. And at Intel, we are working on solutions and modular building blocks that enable you to grow your computing capability in a modular, scalable, cost-efficient way through development of building blocks of all types. We have the Xeon E5 processor, which has been the workhorse for servers and workstations for enterprises. We have networking, 1 gigabit going to 10 gigabit networking, optimized for virtualized environments. We have software we're developing to bring those solutions together. And as you know, as an industry player, we're driving blueprints on how to build data centers. We're driving new standards and interoperability events to make sure that when you deploy the technology in your data center, you have a great experience. And today, though, I'd like to focus on how storage is changing and how you might effectively use new technologies for storage in your cloud and your big data solutions. And I'd like to talk about that in 3 parts. First, I'd like to talk to you a little bit about the storage paradigms that exist today and how those are IT challenges for you. Then, of course, I'd like to talk to you about how solid-state drives address those challenges and actually show you some very specific examples of how that works. And then, of course, at the very end, I'd like to talk to you about some of our solid-state drives, our 3rd generation of drives, and how they will help drive solutions for you in the data center. Now, let's talk about some of these storage paradigms. Today, I think it's common knowledge that hard disk drives, electromagnetic hard disk drives, deliver performance, or the best way to deliver high performance, and you do that through parallelization of those to overcorrect for some of the lower performance of the physical drives themselves. You over-provision them, you short-stroke them, you put them in large arrays in parallel in order to deliver the IOPS that are required for the high-performance applications today. And that only hard disk drives have enterprise-class features. They've been around for decades, and there's been fine-tuning of the reliability and the security and the end-to-end data protection of these drives. And that solid-state drives don't have sufficient endurance. They wear out. Also, that hard disk drives, because of their low cost per bit, are the most cost-effective solution for storage. and that SSDs are just fundamentally too costly for the data center. And what I'd like to do is talk about each of these paradigms and address them through a category of discussion, the first of which is talking about performance, then we'll talk about enterprise class features, and finally we'll talk about how solid state drives can actually be the answer for some of the bottom line problems that you have around space in your data center, around the power delivery into that data center, and around cost, actually. And for the performance side of things, I'd like to actually show you that. And we'll start with a demonstration. And it's a server demonstration. I have 2 servers here. I'm going to start it off because it takes a little while to run a server demo. And what we have here are, what this demonstration is it's a China telecom database with 1 billion records in it and 160,000 records coming in every second. So it's a big data application. And what we're doing, and it's unstructured data, so what we're doing is we're doing a search for all the information associated with a given phone number. We're going to do a query on this data, and we're going to look for all of that unstructured records, the instant messages, the phone bills, emails, et cetera, associated with that are associated with that particular phone number. And we have actually 2 servers that we're going to run it on. Oops, sorry. We can go back one. We have 2 servers that we're going to run it on. We have a legacy cluster, and that is a cluster of servers based on about 3-year-old technology. The processors are the Xeon 5600, and those are 6-core processors or 12-threaded processors. We're going to use hard disks for the storage subsystem and gigabit networking, and then we're going to use the open source version of Apache Hadoop to do the big data queries. Then we're going to do an advanced cluster, which is the modern state-of-the-art cluster, and that is the Xeon E5 series processor with 8 cores and 16 threads, and those parallelism helps a lot with the parallel processing of this data. And then we're going to use solid-state storage, of course, in that, and then we're going to use 10 gigabit networking, and these are twisted pair Ethernet 10 gigabit networking with integrated MAC-PHY that gets our power down and gets our costs down. And then we're going to use an Intel-optimized distribution of Apache Hadoop, and that's the first version distribution that has been optimized from the hardware up, if you will, to take advantage of hardware acceleration features that are in both the networking and the processor infrastructure. And this is going to take a little bit of a while, so I'd like to talk about a couple other things and then come back to this in a few minutes when it's done, and we can do some comparisons. So in any kind of big data problem in this sort of MapReduce algorithm, there's 3 major sections to it. The first is you're importing the data, and you're doing some kind of processing on that data, and then you're exporting the data. And of course, the 10 gigabit networking, the SSDs are going to be very, very helpful at the import and the export portion of the data, and that's probably obvious from the increased bandwidth of the connection to the storage and then the very fast storage. But it's also incredibly important in the processing portion of that big data analysis. And what's happening there, and many of you guys know this, but the MapReduce, what it's doing is it's taking the data and the problem, and it's breaking it up into pieces, and it's distributing it out across the nodes in the network, and then some sort of operations being performed on that data. It's either doing a search or a comparison or a sort on that data. It writes out the temporary information back into the storage. Then it shuffles that back in, does an additional operation on it, and reports out the result of that. So in this case, it's the phone number and comparing it against all that unstructured data. And what you see happening is that operation creates a bunch of random I/O to get at those very unstructured data types. And in the case where the storage is built on hard disks, what you get is some, because hard disks are not so great at doing random I/O, you'll get some stalls in the feeding of that infrastructure. And you get conflict because you're writing the temporary data back out into that storage system, which is also very random and challenging for hard disk infrastructure. So that's one application. Another one is, that's kind of similar, is a cloud application for storage. And virtualization has been a wonderful benefit to the enterprise. When we went from applications that were hosted on a single server, or single server hosting just one or two applications, to doing virtualized servers, we saw tremendous efficiency in the data center. Fewer number of racks, better server utilization, lower power, and tremendous benefit overall to the infrastructure. But what happens when we use a hypervisor in virtualization and put many servers on it is that the storage accesses become much more random. Each server in its application has either a set of storage requests that are either random or linear in nature, depending on that particular application. But when you put multiple servers inside of virtualization, it interleaves those storages and acts kind of like storage requests. It acts kind of like an I/O blender. And again, we end up with incredibly random requests to the storage system. And then again, hard disks, because they're electromechanical devices, have to move around in order to get access to those that random data. They actually have to seek to find those locations as opposed to a long, continuous retrieval of storage. And hard disks are actually have fairly high latency. It's measured in milliseconds, and they're in the range of 200 IOPS. Whereas if you look at a solid-state drive, which is inherently has an inherent ability to do random requests in it because it's a solid-state array of storage, is amazingly faster at that kind of access. It's around 400 times, so it's not just a little bit faster, it's a lot faster. And its accesses, or its latency, is also much, much lower. Instead of milliseconds, these accesses are measured in microseconds of latency. And what that does to the storage subsystem is, in the case of cloud, where you have enormous amounts of random I/O access, a smaller number of solid-state drives can feed much higher random I/O access, so you don't have to over-provision, you don't have to short stroke, you don't have to put a ton of drives in parallel. You can put a smaller number of drives and feed that same high-intense workload. And in the big data case, we talked about the import being improved, in which it is dramatically, and then also the export. But there's a couple of different ways we can use solid-state drives in the big data scenario. One is we can simply eliminate the conflict in the storage by taking a high-endurance technology solid-state drive and make it the temporary storage area. So all of the writes go to the solid-state drive. And what that enables you to do is, because it can handle that high random write traffic, it enables you to eliminate that conflict from the existing hard disk storage array. And that will improve the performance of it significantly. But then you can also, if you have analysis that's very valuable and you want to get near real-time analysis, you can convert the whole array into solid-state drives. And this is really good for developers. So folks that are doing big data developer applications who want to have very rapid info turns on their developer, it's great for that kind of environment. And it's also great for analysis that you want to do that is near real-time in nature, that has a lot of value for you to know very, very quickly. Now, what I'd like to do is go take a look at our server and see how we're doing on our comparison here. And actually, what I see is that our legacy cluster is actually still running. And I realize now, and this is the curse of the demo, that I forgot to start the solid-state drive version of it. And so I think maybe I'll have to talk to you for just a few minutes about something. We'll think of something to talk about while we run the solid-state drive version and hopefully catch up, there we go, with the hard disk drive version. So one of the things that we have in the E5 series, Xeon E5 series processors is something called Data Direct I/O. And Data Direct I/O enables the network controller to write directly to the cache in the processor, bypassing all of the memory. And that's a huge benefit in actually running these kinds of workload applications. And I see actually that we're done now. And I don't know if you've got that up on the screen. And what you see is that the advanced cluster with the latest state-of-the-art advanced technology took about 16 or 17 seconds to run. And the legacy cluster from 3 years ago, the 3-year-old technology, took around 564 seconds to run. So that's the combination of the optimization of quite a few technologies, and I'd like to show you that. And what we see here is the benefit from each of these technologies as we apply them in sequence. So they compound to deliver a 35x, 35 times performance improvement. So taking something that was sort of a coffee break job, or maybe a long coffee break job for 10 minutes, down to something that's near real time in 16 or 17 seconds. And that comes from, one, the processor, right? So it's got a new processor, and we take it from 10 minutes to 5 minutes through the advanced capability in those processor features. Then when we add the solid-state storage into that, we take it from 5 minutes to 1 minute. It's an 80% reduction in the time to deliver this. And then when we use 10 gigabit networking instead of 1 gigabit networking, we take it from 1 minute to 30 seconds. And then when we use the optimized version of the Intel distribution for Apache Hadoop, we take it from 1 minute to about 17 seconds. So it's not that each one of these things doesn't help the other. Actually, there's a compounding effect as we apply these technologies together to deliver the most advanced solution we can. Make sense? Great. So you can see the performances there for those big data workloads. What I would like to talk briefly about is the enterprise class features that we've been integrating into solid state drives as we've been advancing our generations of technology into the enterprise. So we're on our 3rd generation of technology now, and we've integrated a number of enterprise class features into those solid state drives to improve the RAS, the reliability, availability, and serviceability of those drives. The first of which is enterprise class data integrity. And this is taking all of the data and control paths that are inside that solid state drive and putting error correction and error detection on any possible point that data could flow to ensure that we have the right checkpoints so that nothing can ever go wrong with the data once it goes into the solid state drive. We've added protection against data loss in multiple ways, but the most notable way is in power loss. So if we have an unplanned power event in the data center, if suddenly the solid state drive loses all power to it and there's a write in flight to it, it has enough energy in the drive, so there's a small battery or capacitor inside that drive, so that it can complete any writes to ensure that your data is safely stored on the drive if it's been received by the drive, so no data loss. And then we've been working on our controller technology, our algorithms and our optimization and our acceleration to ensure that we have the right level of endurance for both the most high write-intensive applications along with high-quality media or NAND technology to ensure that we have high-endurance applications and we can handle the most high write endurance applications, as well as for most applications which are more read-intensive, have lower cost solutions that enable us to provide a more scalable product line. Now I'd like to talk briefly about sort of the bottom line of deploying these technologies into your data center. How does it impact my space, my power, and my cost of my data center? And I'd like to do that through an example. And over here I have a typical rack, virtualized rack with 500 VMs running on it, and you can see the VMs running here on the monitor. And you can see the configuration associated with this, right? There is 500 VMs running on this, 42U of drives on there, and then the associated power associated with that. And what I'd like to ask you is what would happen if we were to replace the the IOPS needed out of that storage with solid-state drives. What would a rack like this look like if we replaced the needed IOPS with solid-state drives? And I'd actually like to show you that, because what we've done is, if I can open this, there we go. What we've done is actually build that inside of there. And that's what your rack looks like if you use solid-state drives instead of hard disks. We go from 42U down to 2U of storage. And all of the consequential power associated with that comes along with that. So that's what the inside of that looks like, and that's built with a Supermicro server, Nexenta virtual SAN, and VMware hosting. And if you look at the comparison of those two rack solutions, we're still supporting 500 VMs, and our storage cost to deliver the IOPS needed for those VMs goes from $145,000 down to $12,000. And our rack space goes from 42U down to 2U, and our power drops by over 100x. Now that's enough storage to handle what those 500 VMs need, but if you did need a little more storage, you've got $133,000 left to spend on SSDs if you want to. And your operational costs will still be lower. So what I've attempted to show you is that from a performance standpoint, solid-state drives are a much more efficient way to deliver storage bandwidth and lower latency than parallel hard drives. That we now have the enterprise features in these drives to make it a very solid and reliable technology to deploy out into your data centers. And that if you do deploy this, you have an enormous opportunity in improving power, cost, and rack space in your data center. Now at Intel, we have a broad portfolio of SSDs for the data center. We have cache acceleration software that works across all of those drives. And that cache acceleration software is for when you want to deploy some SSDs in front of your hard disk drives. It enables you to just cache the hot data. So if you have a workload that has tight locality, it can make sense to just initially deploy, for example, one of those 910 series PCIe add-in cards with the cache acceleration software. And you'll get a tremendous improvement in performance just from that one drive or that one cache solution if you have tight locality in your code. And you don't have to replace all your hard disks initially anyway. And so that's a tremendous solution for us. That 910 series product actually is our highest performance product, and the PCIe add-in card form factor has very low latency, very high performance associated with it. We then have our high endurance product, the DC S3700, and so that's in a 2.5-inch form factor, SATA interface, and that delivers great performance for write-intensive applications. And then yesterday, here at the Cloud Expo, we introduced the latest member of this family, and that is the DC S3500 series product. And that product has the fast, amazingly consistent performance that those of you guys who've seen the 3700 and seen its award-winning performance and consistent performance have come to appreciate. It has that stress-free protection, that end-to-end data protection, that power loss protection, but it is a read-focused, a read-intense application-focused drive, and with our 20-nanometer process technology, it brings the cost and the power down in that product to make it a much more broadly deployable product into the enterprise. And that product is one of our third generation of solid-state drives. We did our first for enterprise. We did our first enterprise product back in 2008, and that was the X25E. And that was to focus on the problem that I was talking about earlier around random IOPS. And the focus of that drive was to deliver tremendous performance in average IOPS for read and write. In our second generation product, we learned a lot from our customers, and we focused on the endurance factor. So there are some applications that have high write intensity, and we enhanced that product with high endurance technology. And then in the third generation, as well as improving the performance, and in the third generation, we focused on improved performance, but consistent performance, and I'll show you what that means in just a minute, as well as enhancing our high endurance technology with new controller and new algorithms. And we added this end-to-end data protection into the drive because some of our customers wanted to have that level of data assurity and data integrity in the drive. And it's the 3700, which was relaunched last year, was launched to rave reviews on our 25 nanometer process by the industry. And this AnandTech quote here is, I think, a great example of that response. We've seen tremendous response from our customers, and we're beginning to see that same response from the 3500 series product. And I mentioned consistent performance, and I want to talk about that just a minute. What we learned as part of our second generation of products is that it's one thing to have high average random IOPS, but it's important for those IOPS to be very consistent because many applications want to be assured that a transaction is completed by a certain time, and they're looking at your 99.9 percentile of how long your latency is to complete a given transaction. And if you have a wide distribution in that, and like the picture on the left is one of our competitors' drives, and actually many of them look like this, most of them look like this actually. What you get is a much actual lower effective performance if you're waiting for that final, for that 99 percentile. And if you put it either in a soft RAID or a RAID controller configuration, and you stripe your data across multiple drives, which is a common practice we found, that the latency of getting the data back is dependent on the slowest transaction. So if you have 5 of these drives in parallel, you see this impact where the slowest of the drives, the slowest data points are multiplied by 5 times. And so you see a much lower effective performance if you have great variability in your workload. Now, we've done our latest drive, this 3500 series product, on our 20 nanometer process, and that has benefits to the IT professional in that it allows us to get more gigabytes. We build these big wafer factories, and then it allows us to get more gigabytes per wafer. It allows us to bring the cost down on that product. And indeed, that 3500 series product is priced significantly below our 3700 series product. It also has impact on power. And this is a 1.6 watt average power. And this is an example of, the bottom picture here is an example of a SAS hard drive, a thermal graph of a SAS hard drive and then a solid state drive, 3500 series running under a workload. And you see the higher temperature and then hence the cooling cost associated with that SAS drive. And then with the solid state drive, a much lower temperature and hence a lower cooling costs, in addition to the fact that you won't need as many to deliver the random IOPS. And as you might expect from Intel, we've worked for broad industry support of these drives. So we do interoperability testing with hundreds of server configurations. We work very closely with the OEMs who are system builders, bringing solutions to you so that you get a good experience so these are readily available to you and you get a great experience when they're delivered through the OEMs. We work very closely with the adapter drivers to ensure that we get good interoperability with those drives, and of course, with the software industry, looking at the various operating systems, ensure that where there's a compatibility suite with them, we're checking to make sure that things work well, because we want you to have a great experience when you integrate the drives into your data center. And so we've been working with the industry leaders, and I actually wanted to bring one of the industry leaders in hybrid cloud up to talk to you for just a minute about how she's using it. And Lisa Larson from Rackspace has agreed to come up and talk with you a little bit about how they're using them. Hi, Lisa.
Hi.
How are you?
Good to see you again.
Good. I hear you guys have industry-leading technology, and then you have about 100,000 customers.
No, you're a little bit off. It's more closer to 200,000 customers that are using our hybrid cloud.
So that is scale.
Yes,
so
yeah, huge scale. Lots of servers, lots of storage.
Great. Well, maybe you could tell us a little bit about what's going on at Rackspace, how you're using SSDs, and
yeah,
what's cool about it.
Definitely interested in talking about that. So we're using SSDs across our hybrid cloud platform, and we have a number of options available to our customers. Across hybrid cloud is dedicated infrastructure. We call that our bare metal, more of our managed hosting type of platform. And then also, of course, public cloud. And we're using SSDs across both of those platforms. But let me drill into the public cloud, because this is where we're using Intel technology. So we're using the Intel SSDs for cloud block storage platform. And the reason why that we chose Intel there specifically is a combination of price, performance, and durability. And those are the three things that we really saw: price, performance, durability.
Great.
And also, on the performance front, I want to take a look a little bit at that, is that over SATA drives, we saw a 6x performance gain of the SSD drives.
At the application level?
Yes, absolutely. Yeah. So you can see there's a number of use cases where we see SSDs coming into play across NoSQL, large media. Those are all the different types of use cases that we're seeing. So, in summary, it's really price, performance, durability. But I think one of the key drivers and the reason why that Rackspace is choosing Intel is that Intel has been a key development partner for Rackspace in our hybrid cloud platform.
Great. 6x performance, price performance.
Absolutely.
Thank you very much, Lisa.
Thank you.
Thank you, Lisa. So, of course, Lisa and Rackspace are tremendous leaders in the industry, but what we're seeing is that although not everyone is as advanced as Lisa, the overwhelming majority of the customers that we survey are planning to deploy SSDs into their enterprise, and that the industry analysts are projecting tremendous growth of that solid-state storage into the enterprise. So the overall majority installing, and about 100% compound annual growth rate of solid-state drives into the enterprise for the next few years, actually. And what I'd like to leave you with is that big data and cloud applications are driving this need for fast random storage. The applications and the computing capability is driving a change in how storage is accessed, and that SSDs are shattering some of those original thoughts about the way storage should be used in the data center, and that the family of products from Intel are designed for data center users, and these new capabilities on our third generation products are set to unleash deployment of solid-state drives into a broad set of data centers. On that, I'd like to thank you, and we'll see you over in the booth later on.
Thank you so much, Rob Crooke. As Rob mentions, of course, you can see the Intel booth, hard to miss, over on the show floor.